These are notes for section 10.5. Okay, so 10.5, we're doing a lot of calculator work, doing logs quite a bit, and some LNs, as you can see. Okay, so page 598, 1 to 73 odd. So here we are. Some more. And up to 73 odd, looks like. Okay. And then answers in the back of the book. 10.5, here we are. Scroll over a little bit. And some more. I don't think we have to go that far, actually. All right. Okay, so what you want to get comfortable is your calculator. So let me show you how some calculators work. Okay, so the calculator I have here, it's a TI-85. There's a log button. Log means log base 10. Above it is 10 to the x. To get the upper function, you normally have to hit something called a second function button. Mine is yellow, but I've seen green, red, blue, doesn't matter what color it is. It's normally up here to get the upper register. There's also ln, which stands for natural log or log natural. Above it says e to the x, and there's a second function. Okay, this is a graphing calculator. If you have a regular scientific calculator, that's okay too. So on this calculator, it looks like there's ln and e to the x above it. There's second function. And here's log. Log means base 10, and there's a tiny little 10 to the x there for second function. So I'll be demonstrating both of those for you. Okay, so let's see. Log x of 2.8802. Okay, that's problem 21. How do you solve it? Okay, the original problem doesn't have the 10, but we're going to put the base 10. Okay, so it's 10 raised to the 2.8802 equals x. And if you punch it in a calculator, it's about 758.9270. Okay, so 10 to the x. Okay, so on this calculator, 10 to the x is right here. So I'm going to hit second function log, and my calculator pops up with 10 to something. And they want 2.8802, 2.8802. And there it is, 750.92699, something like that. Rounded off to 758.9270. Okay, I'll show you some problems involving this calculator also. Okay. 23. Problem says log x, that's log base 10 of x, equals negative 2.1198. Unscramble it, 10 to the negative 2.1198 equals x. Okay, so you can just type it in on this calculator. For those of you who have a regular scientific calculator, you might have to hit this backwards. So let me show you how to do it in this calculator. 10 to the negative, whatever. First, you have to get the negative number in. Okay, this calculator works backwards, and there's a plus or minus key, which changes a positive to a negative and vice versa. So to do that on this calculator, I first have to type the 2.1198, 2.1198. Okay, and then I hit this plus or minus button. So if I hit that, it pops up with a negative. Then I do second function 10 to the x, which is this button here. You can't see it that well, but yeah, there we go. Above the log says 10 to the x over there. So second function 10 to the x, and there it is, 0.007589, something like that. Okay. All right, so let me pause and show you some of the problems at the beginning, which are basically just punching in your calculators. Okay, so number 1, log of 378. Okay, so log of 378. On this calculator, here's my log button right here, log, so I hit log, and then 378. So there it is, 2.5775 to 4 decimal places. Okay, and then maybe something like 9, log of 37,800. So log. Okay, now, some of your calculators, once you hit log, it might pop up with a left paren like that. If that happens, then you have to close it with a right parenthesis. Okay, so let's say I'm doing problem number 9, 37,800, 37800. You have to close it with a right parenthesis. Okay, so 4.5775 rounded off. Okay, and then maybe something like 17. I'll do it with the scientific calculator where you have to hit it backwards. So for 17, some of your calculators, you have to hit the number first and then log. Okay, so 0. Let me clear it, 0.0314. Can't really see it there. Oops, here we are. And then I hit log, which is right over there. So I hit log, negative 1.5031 rounded off. Okay, so just experiment with your calculator. See what your calculator behaves like. Okay, some more problems here. Problem 31 says log of x equals 10. You pretend it's base 10. So 10 to the 10 equals x, unscramble it. Okay, so 10 to the 10, you don't really need your calculator, just put a 1 and then 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's the answer. 37, log of x equals negative 2. Okay, the original problem looked like that. Sneak in the 10. So unscramble it, 10 to the negative 2 equals x. So x is 1 over 10 squared, or 1 over 100, or 0.01. So the answer is 0.01. Okay, and then 39, I'll show you what 39 says. It says log x equals log base 2 of 8. Okay, so you pretend there's a 10 here. Okay, so it's going to look like this. All right, now first I work this out. It comes out to be 3. Okay, so temporarily I'll say log base 2 of 8 equals y. I shouldn't use x because that's already used up. Unscramble it. 2 to the y equals 8. What exponent do I want? I want 3. So y is equal to 3. Okay, so this thing right here is equal to 3. So now I'm doing log base 10 of x equals 3. Unscramble it. 10 cubed is x. X is equal to 1,000. Okay, now we have some problems involving natural log. ln stands for natural log, where the base is e. E is about 2.7. So there's an ln here, and above it is e to the x. Okay. What's the value of e? It's about 2.7. It's an irrational number like pi. It never terminates, never repeats. So I got a pi button. You've heard of pi, 3.14159, blah, 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 blah. E is also kind of weird. I'll show you the number e. To get it, I would do e to the first power. So second function, e to the 1. So e to the 1 is obviously e, and there's e. 2.71828, something like that. Okay, and just for fun, let me show you pi, 3.14, right? So it goes on forever and ever, never terminates, never repeats. It's an irrational number. Okay, so ln x equals negative 1. ln means log base e. So log base e of x is negative 1. Unscramble it, e to the negative 1 equals x. Okay, so I punch out e to the negative 1 on my calculator. Okay, so e to the negative 1, it's an upper register function, so I have to do second function, second e to the x. Again, if your calculator automatically gives you the left paren, let's say if it automatically gives you that, then you got to close it. Okay, then we have the exponent is negative 1. So my negative button is this one here. Don't use this one. That's a subtraction. You can tell it's subtraction because with all the other arithmetic operations, right? Divide, multiply, subtract, plus. So that is subtraction. This one is to make a negative. So negative 1. E to the negative 1. And hit enter. 0.36787. So round that up to 0.3679. Okay. 43. Log of x is 2 log 5. Make the 2 climb back up. Log x equals log of 5 squared, which is 25. So if log of x equals log of 25, that means x is equal to 25, right? Log something, log 25. I guess this better be 25, right? Similar theme here. ln x equals -3 ln 2. Make the -3 climb back up. So it looks like this. ln x equals ln 2 to the -3. Okay. So now x equals 2 to the -3. I mean, think of it this way. You have ln something behind my pen equals ln 2 to the -3. Now that ln matches that ln. What do you think has to be behind my pen to make it true? 2 to the -3. So x is 2 to the -3, which is 1 over 2 cubed, 1 over 8. (47) says ln e is equal to x. Okay. Well, ln means log base e of e. Okay, e is no longer a variable, it's a real number. Okay, unscramble it, e to the x equals e. What exponent do I want? I want 1. Okay, 48 I wanted to show you, even though it's even. ln 1 equals x. This means log base e of x equals 1. Unscramble it, e to the x equals 1. Well, we know anything to the 0 is 1, so x is equal to 0. Okay, 51, ln e to the x is y. ln means log base e, so log base e of e to the x equals y. Unscramble it, e to the y equals e to the x. Well, if that's true, that means y is equal to x. Okay, that means ln of e to the x is just x. Okay, 53, log of 10,000 equals x. The base is understood to be 10. Unscramble it, 10 to the x equals 10,000. So what exponent do I want? I want 4. So the answer is 4. Okay, ln of 1 over e cubed equals x. Okay, this means log base e of 1 over e cubed is x. Unscramble it. E to the x equals 1 over e cubed. 1 over e cubed is the same as e to the -3. So e to the x equals e to the -3 means x equals -3. Okay, then 57, log of square root of 1,000. Put a 10 here. It's understood to be 10 in red. And I'll call it x. Unscramble it. 10 to the x equals square root of 1,000. Okay, now, 1,000 is 10 cubed. Square root means 1/2 power. So I'm going to rewrite this as 10 cubed to the 1/2. And then when it's written like this, I can multiply the exponents. 10 to the 3/2 equals 10 to the x. Therefore, x equals 3/2 or 1.5, like so. Okay. Right, so that's it for section 10.5.